So, Martin asked if I could speak about building energy codes and how they are crucial for energy savings and comfort. And I said, sure, I'd be more than happy. And so there's who I am. I'm the director of the buildings program at the Southwest Energy Efficiency Project. We're a nonprofit. And I've been working on codes for the last 20 years. The energy code specifically, some IRC, some IMC, IRC residential code for IRC residential code, IMC mechanical code, both residential and commercial, but mostly the IECC. And I've been involved with the organization that develops the codes, the building codes, the International Code Council. Been on a number of committees the last 2 years, 2 cycles, I should say. Let's see, is my, yeah, oh, you just can't see it on the TV screen. So I was on the 2021 IECC, and that is this code right here. And I am now on the 2024 IECC. Every 3 years, they develop codes, all the codes. It's kind of brain dead at times. It's pretty painful to participate in the process, but I really do enjoy it. And there we go. So SWEEP, let me draw a little map. We're one of 6 regional energy efficiency organizations. We cover the Southwest. We do similar things as these other organizations, NEA in the Northwest, NEEP in the Northeast, SEA in the Southeast, MEA in the Midwest, and SPEAR down in the Texas area. Do similar things, have some of the same funding to work on driving energy efficiency through the economy. In many areas, we have people on staff that work on transportation. They're working on EVs, and they're working on mass transit, and they're working on a number of. We have staff working on utility programs, driving efficiency programs through utility programs, looking for opportunities there to with renewable portfolio standards and electrifying that part of the grid for the utilities. So we actually have support in 5 states. We do not have. We cover Wyoming. I don't know Wyoming's in the Southwest, but it is. It was before I came along to the organization. But we don't have a staff person there. We have staff in all of our other states. So those are the codes. What's interesting now is the NEC. I never had any discussions about the NEC all the years that I was working on codes until the last few years, because of all this discussion about decarbonization, electrification. Never had a discussion about the NEC. Wasn't brought up in any of these conversations. But now it's there because we're looking at the panel capacity loads, that electrical loads. We're looking at the NEC as how archaic is the NEC? Does it recognize that we have all these LEDs and we have all these efficient appliances and so forth? So that's part of the conversation now. I know the front cover, that's about it. And I know a little bit about some panels. But that's now in the conversation about codes, and it wasn't before, other than the electricians. So this is just a diagram from the Pacific Northwest National Lab of where the energy codes have come from and where they're going. And the goal is to come down to this corner by 2030. That's the goal. And we're on our way. In some cases, we've stayed at one area for a long period of time. So you can see green is commercial, that's ASHRAE, and blue is the residential, the IECC, International Energy Conservation Code. And so we got stuck from the 2012 to the 2018, and now we saw about a 10% increase to the 2021. And I'm really going to focus on residential. There's not enough time to go into all the different commercial building types, and then that conversation would be around the ASHRAE standard. And I used to participate in the ASHRAE 90.1 committees years ago when I was working for an insulation trade association. So that was 13, 14 years ago. So 9.4% savings with Department of Energy analysis for residential. Commercial, it's 4.7%. And this is from the last year. So there's a requirement statute that they have to assess every time a code comes out, ASHRAE and for commercial and the IECC for residential. They have to assess, is there energy savings from year to year? And that came about from the 70s when we had that big oil embargo and all the energy crisis and so forth of those days. So complexity. This is the 2006, and I worked on the development of that. Look at how thick that is. Not very thick, and that's residential and commercial. This is residential and commercial today. The majority is commercial. Residential is about that amount. Commercial is this. Much more complex, much more pathways for a designer, a builder, trades to build to the codes and standards, but much more complex areas that are in the code. Commissioning is in commercial codes. It wasn't in 2006. It wasn't there in 2003. But if we're going to get to that corner of the graph, we're going to have to add some more complexity. Years ago, a fellow at the Pacific Northwest National Lab, Dave, said, let's just simplify everything and just come up with a number, MMBTU per square foot or kilowatt hours per square foot or something like that. I like that idea. Then we'd have guides like this thick on how to get there. But that would definitely simplify the code. Just have a number, and then you'd have to use software. The codes today still allow a prescriptive pathway. Read your table, put that amount of insulation in, put that kind of window in, or better, to build. And as I was in the insulation industry years ago, that's going to be a tough one to move away from the prescriptive, because the manufacturers like to see what could potentially be their product. You can't call out this insulation, you can't call out that window, but they like to see that it's an RX, whatever it is, because they make a product that's an RX. So I think we're still probably not till the 2030 timeframe when we'll start to see prescriptive move out of the code. But that's still there in California too. So codes and standards have been around for a long time. You've heard about King Hammurabi, okay, in Babylon, and he had his, if it falls, if a builder builds and it falls and kills the owner, then they're put to death. And then, of course, in Rome, they had all kinds of requirements around around their water requirements. And they also had requirements on their buildings so that they wouldn't tumble over. So they started at 70 feet, they moved them down to 60 feet. They weren't into the energy efficiency that we're talking tonight, but codes and standards of some level have been around for a long time. And of course, the Chicago fire and San Francisco and on and on. And the insurance industry saw the value of codes and standards too. So I tend to call it progress, not perfection. The code is not perfect by any means. It's developed by humans, and it's developed by building officials and product manufacturers and efficiency advocates, a whole different mix. And so we're progressing to that goal, but it is not a perfect code. And so that's why the codes are developed, that they're model codes so that you can amend them at a state level or at a municipal level. And so I'm going to show you some of the things that are in the code today, the newest code, the 2021, and how that brings comfort and building science. So some of the complexity we talked about here, it's because there's been so much that we've learned about how buildings operate, how they perform. And that is filtering into the building codes, and it's filtering into the energy code. There's pushback. There's certain industry that doesn't want it. They'd like to continue to build from the 2006 code if they could. But they're also recognizing that things are changing before them, especially around electrification, especially around EVs and so forth, that they are becoming more open to some of the policies. I'm not calling out names right now. And they would like to see some of this included in what's called an appendix. An appendix is part of there's your code set, and then you have some appendices. And it's not mandatory unless a state or a municipality brings it into their amendment package. And then it becomes, but it's developed and vetted nationally, an appendix. So what do you see here in this wall? This is a wall. This is a house. It's in the northeast. It meets the code. What's going on? And that's a finished wall. What do you see? No, it's not. You can't see it. It looks almost like ship lap right up there. So what's happening? That's a code-built house in a cold climate. He is, but what's in the wall assembly? How do you think that wall is built? Okay. It has insulation on the exterior. From what I remember, it doesn't. It's not SIPs, but it's insulation. Yeah, it's an insulation on the outside because of the value of removing that thermal break in the wood. And so that's in the code today. Wasn't in the code years ago, but it's in the code, recognizing from a building science perspective that you eliminate that thermal break, that building enclosure, that building shell is going to perform better. It's going to bring more comfort. And yes, so he's doing an IR scan on that house, showing that it looks good, but from the inside it doesn't, because all the insulation's to the outside. So this is a table that gets caught up at municipalities, gets caught up at states for development. And I apologize, this was taken right out of the code, and you can view these codes for free on the ICC website. And so here's where you see there's a 30 on the inside. They're going to put, and the very bottom, 30 on the inside, or it's a 20 in the cavity, 30 in the cavity, excuse me, 20 and then 5 continuous on the outside, or 13 in the cavity and 10, or nothing in the cavity and all the insulation of R20 is on the outside. So that's what it shows in this prescriptive table. And so you can see also that things have gotten much more insulation, not to passive house standards, but they're getting closer. You've got R60s in the attic in our climate, prescriptively, and I'll explain that performance. That's our baseline. And then even down in Phoenix, it's an R49 in the attic. And then the windows, fenestration is improving. I think they could drop them more, and we'll see them drop more in the 2024. And then especially the solar heat gain coefficient, they can go even further on that in the hot climates, Phoenix, Tucson, Las Vegas, those areas. And so we've improved the fenestration recently to a 0.3, so you're basically in an R3 window. Still, you can have better windows than that, but it is improving, and it's progress. It's not perfection. So it is hard to see this picture. I took this about 9 years ago in a production house in Castle Rock. And the U factor is 0.28 in a production house about 9 years ago, 9 years ago. And then the solar heat gain is 0.33. So these windows have been around for a long time. And production builders won't put in the most expensive windows. They want to get the best value for the product that they produce. So the example of the NFRC, that's a good value. And again, we saw it years ago. The limitations that we have in our climate with a double pane, two panes of glass, is manufacturing here, and they use different types of gas within that window assembly, that IGA, and so most manufacturers are manufacturing outside of Colorado, and they have to bring them in. And so when you're coming in from a lower elevation to a higher elevation, becomes a challenge. So going to a triple pane can get us there. They're much heavier if it's all glass. They've got a lightweight triple panes. They have R5 windows that have been around since the American Recovery and Reinvestment Act that was signed into play when President Obama was in back in 2010. That funded development for R5 windows, and there were manufacturers that were developing those products at that time. So we can continue to drive down the windows, and the cost really is no different. In fact, Christine Brinker, one of my team members at SWEEP, she was working on this one code bill that was signed, or that passed. I don't know if the governor signed it today. Did anybody hear if he signed it today? The energy code bill? Yeah, there's an energy code bill. I'll explain that. And so I went to Home Depot and I went to Lowe's and took pictures and on my cell phone, and I'm texting them to her in the evening, and everything exceeded the energy code that we're looking at today. Solar heat gain coefficient. So in our climate, we wanted the solar heat gain coefficient to be a higher number to allow the sun in and to warm. And in Arizona, that's critical to drive that down. The other thing that I'm not showing here is that came into the code is something called visible transmittance. That is what's that? How much light is coming in? Right, exactly. So years ago, you'd see more of like a tinted window with these more efficient windows, but now the VT has gone up. So there's more light coming in, even though the solar heat gain coefficient may be low. And that's just those engineers and scientists that are working in that space, developing low E applications on glass. It's pretty cool what they're doing. So for Windows, here's where I was talking about recognizing, we didn't do that a few years back, recognizing the challenges of bringing in efficient windows into higher elevations. So now we do there's some limitations. It's not as efficient, but there's known limitations until the industry can catch up and start producing those products that can keep the solar heat gain, the U factor down, and ship them into a higher elevation. And then also, there's this piece about wind debris, recognizing that you go here along the southeast, the Gulf area, where you have hurricanes and sustained winds and so forth, that there's a different type of window application that can be applied in those spaces, and the window won't be as efficient in those areas because of that wind. And we have actually a little bit along our front range, some wind, but not to the level that's down in the hurricane-prone regions. So this is one table that came into the code came into the code the year after this one. It came into the cycle after this one, 2009. You heard of the Energy Star thermal bypass checklist? That's basically what we've got here. And we go back and forth. In fact, we were probably 2 hours on this table today for the talking for the 2024 code. Where is it too much of a guide? Should it be more of a code? But that was the whole idea here, is that we took the basics of the thermal bypass checklist and moved it into the code. Again, building science coming into the code, so that we're not building these buildings and then we're having issues with mold, well, mostly mold, or any other resiliency impacts to the longevity of that building. So this is a renovation. You can't build this way by the building code. You can't put a vapor retarder in a basement application because of moisture that could get trapped back there. So the building science continues to move into the building code so that buildings are more durable. And years ago, homes that were built in the 70s with no insulation, those the wall assemblies could dry out. There was no insulation there. And now we're putting insulation in there. And now we're putting OSB, not plywood. And we're doing a number of other things that we didn't build houses that way in the 1970s or 60s. And so as the building materials have changed, the building science has changed too. And as we're filling those cavities with insulation and air can't move through and can't dry as easily, vapor retarders, vapor barriers, those depending upon your location, depending upon your climate zone, is it dry, is it humid, is it moist, will tell you where you should put your vapor retarder and what you could use. In our climate, we can get away with latex paint as a vapor retarder. So leakage is a big one. And we have recognized that the code really just focused on single family. It didn't have a good take on multifamily or attached units. So you've got those common walls there that are not sealed up. Some are a wall assembly, a UL assembly. And so there's limitations that you can do in those attached units, depending upon the materials you're using. And so, and recognizing that the industry for years has been looking at an air change per hour in a building, and that's volume based. And so bigger buildings, bigger houses did better with an ACH test, or the same test, but it looked at the air changes per hour via volume versus cubic feet per minute. And so now the codes come in, okay, if you've got an attached unit, if you have a smaller single family, 1,500 square feet or less, then you can test with the CFM, which is more accurate in the smaller units. You can't test that in the larger, though. The code doesn't allow you to do that. I see that one day where it'll come and move to CFM. I mean, that's what you look at in weatherization. You're looking at your CFM. So all these buildings now can be tested and use that CFM calculation instead of. It's fairly close. That's a good question. So they had to look at it. It's not equal. It's somewhat equivalent. That would be, what I understand, it's higher than 3 ACH. It is higher than 3 ACH, but it's not 5 ACH. It is higher. And so, but it's close. And the one thing about our codes is there's different pathways. You could build by a table, or you follow everything that's in the table. R this, R that, U that, SHGC this. And then there's pathways where you're going to use a service like an energy rater. And you're going to use software to calculate the energy of the reference house or the reference building per the code, and then how it's designed and expected to be built. And so those are other ways and that take into consideration some other opportunities that you don't get prescriptively. But in all cases, the air leakage test is required in all the pathways. It used to just be in that software, that calculation, the HERS rater. That was the only pathways that would require leakage. But now air leakage is required, duct leakage is required in all the pathways. And then this is beneficial again. 3 stories or less, I'm talking residential. 4 stories would be a commercial building. But this example right here is 3, and right along the side, I took that picture, there was a 4-story. And so that's residential and that's commercial. They probably, when they submitted their plans, they probably submitted it all commercial, is my guess. Right. Good question. Okay. Good question at the end. But they're filtering into the code today. So testing's mandatory. And per dwelling unit, there's different requirements. If you choose a different pathway, there's a limitation. You used to be able to trade off to any leakage rate. Now, you can only trade off to a certain level. You can't have it leakier than these levels. So that's a new improvement in the building codes. That's going to continue to bring comfort to the occupants of those buildings where they're not excessively leaky. So duct testing, we've had duct testing in the code for many years. It started out just as prescriptive. It could be the building inspector could visually look at the duct and say it was okay. No. And then it shifted to, okay, if it's inside the building conditioned space, then you don't have to test it. If it's outside, then you have to test it. And now it's wherever it is, you have to test it. Inside conditioned space or outside conditioned space. So recognizing that you still want the air, the cool air or the warm air to move and not have excessive leakage wherever that is, in a crawl space, in an attic or whatever it may be. Did you have a question? Okay. That's right, I'm not supposed to answer any questions. Sorry about that. So that's a new one. And we see in some of the climate areas that I work in, the ducts all reside in the attic. Arizona, they build on slabs. There's no place to put the ducts. There's no basement. So the ducts all go into the attic. Las Vegas, all the ducts go into the attic. And so they are taking, they've been taking their insulation and moving it up to the roof deck to condition, semi-conditioned, because as a semi-conditioned area, it qualified that it didn't have to be tested. Anything within, it did. But there, they stuck the HVAC equipment up there, and they stuck the ducts up there, and so they didn't have to test. Well, now they're having to test, which is good. You don't want a leaky system that you've not tested. So duct insulation, I'm looking at my time, doing good. So duct insulation in floor cavities that's been an area where there's been complaints of comfort, where a living space over a garage, that's been very uncomfortable. So hot or cold, depending upon the time of year, and the garage was hot or cold. And the upstairs was, again, it was opposite. And so what is happening now in this news code is, okay, you're going to put ducts in those floor areas or the garage. You're going to have to separate from the unconditioned space to the bottom of that duct an R19 in the floor. And there's a diagram of it. So it's saying, so you see how they fur it down. Well, back in, I don't remember, it was 2006, 2005, when I was an energy rater, and I was the director at East Star, Colorado, builders were framing it down then. So there were some builders that were already framing it down, recognizing that the duct wasn't sufficiently insulated. But for the most part, builders just throw it up there and they fill it with insulation, but there's minimum amount of insulation depending upon how close it is to the drywall in the garage. And then also anything in the exterior wall, there has to be an R10 now, minimum. We've pushed hard for years to get the ducts out of the walls. Get the ducts out of the walls, run them inside chases, whatever, but get them outside of the walls, because you're not going to have much insulation there. And you're going to be heating and cooling that area. Now, that's typically gas forced air systems. As we move to heat pump systems, it could still be ducted, but it could also be cassettes throughout the home. So you don't have to worry about the ducts, and you wouldn't have to do the duct testing and all of those pieces too. That would go away. So this is new. That wasn't in the code before. It's like, okay, we were testing our ducts. We're insulating our ducts, but there's a lot of other things that we're missing. We've got the bathroom fans. We've got exhaust fans that are not being tested. Are they operating as intended? So you might put a 80 CFM or 100 CFM fan up there, but if depending upon the length of that duct run, you got all kinds of friction there. How many bends, how many 45s, how many 90s, and so forth. And so now this testing requirement is coming in. And I've been working down in Arizona with some communities to move to the 2021. The home builders don't like this testing. It's additional cost. They see it as $300-400 a house to do this kind of testing. Well, that might be true when they first start, but the cost will come down. Those that do the testing, the raters, energy raters, will be bringing their costs down as more and more of this gets tested. But this is new too. Again, looking at these pieces that we've had in the code, but have they really worked? Have they really brought comfort? Have they really moved the moist air out of the home, out of the bathroom? And so this is now in the code. These pieces and parts were also in the Energy Star New Homes program, as those have filtered into the code. So, and the other thing that's happening is ERVs and HRVs are coming into the cold climates. They're in the code now. I see them coming into the warmer climates, climate zone 5, like where we're at. They have to be balanced. That's the picture right there, and they have to have a certain level of heat recovery. Okay, ERV or HRV, energy recovery ventilation or heat recovery ventilation. What I understand talking to the industry is HRVs are on their way out as they're moving to ERVs. ERVs have been used in energy recovery ventilation. It's taking outside air and it's bringing it in. It's taking inside air and it's sending it out. And there's a way to mix it. And so you don't cross the air. but it's able to transfer the temperature between the inside air temperature and the outside air temperature. So it's tempered coming in is what you're looking at. And the ERV, energy recovery, is able to take care of the latent load, take care of that humidity, which we're blessed for not having that in our area. But you get down to Houston and you would want an ERV that could take care of that latent load and remove that, where an HRV, heat recovery, cannot. So what I'm hearing from the industry is HRVs are slowly moving away because an ERV does everything that an HRV does, but it also handles some moisture. And we can have moisture up in Aspen just as much as a Houston house, especially in the wintertime where it's all closed up. You're cooking and you've got many people in there and there's a lot of humidity, and where's it going to go? In the past, it just went out an exhaust fan. It could be centralized exhaust fan, but ERVs and HRVs are going to become more and more popular, and even more so with heat pumps. Because heat pumps aren't bringing in outside air; they're just they've got their fan, their cassette inside, and it's moving air internally. But the HRV would be something that would then be able to take that air and move the old stale air, bring the fresh, clean air in, and mix it so it's temperate, whether it's hot or cold. Hot water efficiency. There were some proposals to bring in heat pumps as heat pump water heaters as a mandatory requirement, or at least one of the options. That didn't make it in. But compact of hot water systems. So years ago, think of older homes built in the 70s and 60s. And if you had a 2-story home, you could walk in and you could see where the bathroom is on the main level. And it's right above you on the second level. They didn't have bathrooms spread throughout houses like they've done in the 80s and 90s and the 2000s. And so compactness of hot water systems, that's the idea, is that, again, you bring all of your fixtures where you have hot water and bring them close to one another like they built homes 50 years ago. And so that's a credit. That's on a performance path, but that's coming prescriptively. And in one city I'm working with, Scottsdale, they're bringing that in prescriptively. That it has to be designed so you're not running all this hot water. You're not wasting all this water going to a faucet that's going down a drain. So it's not a water efficiency, but it's looking at the energy that it took to heat the water and then the loss of the water going to the fixtures. There are some options there where you can use a recirculation pump, an on-demand. I have an on-demand. I love it, my on-demand system, and that works great. So that's an option in the code. And so here's you're just gonna look at compacting where all your fixtures are. That has to be in the plans when it's submitted. And so this is just another example of a drawing. And then they've got a compactness ratio depending upon the size. And there's a hot water distribution factor, system factor. So the larger the area, the larger the number. So that would be negative. And I'm getting close. So what's interesting about the codes on the commercial side, the lighting requirements look at all of the building. So you're looking at this building. If you built it new today, the code would be looking at this lighting, would be looking at the lighting in the hall, would be looking at the lighting, the exterior lighting on this building. So, but for residential, there's been no external lighting requirements. And so now new requirements have come in, but it's at a level where single-family homes, townhomes are not going to be impacted. But there are 3-story multifamily developments that are designed to the residential energy code, and now they're going to have to follow the commercial exterior building lighting requirements. So there's some recognizing that it's a commercial building. It's just 3 stories, and so it was designed under the residential code where it didn't have those lighting requirements, and so that's a benefit for the property owner, and then of course the tenants that are living in there that pay that utility costs through their rent. And then there's some new requirements for within residential for occupancy switches. So if certain rooms, you'd have an occupancy switch. So you walk into the room, lights are going to come on. You leave the room after a while, lights are going to go off like they are already in commercial. So there's energy savings opportunities there. Now this is hard to see. There's a zero energy appendix for residential. There's a zero carbon appendix. This is zero energy for residential. There's a zero carbon appendix for the commercial buildings of the IECC. And so the way it's broken down here, you have your climate zones. We reside in climate zone 5 here in Denver. And it says, okay, your energy rating index, think of a HERS rating, or HERS rater, that's an ERI, has to be a 47 without any renewables. So that building has to hit that number, 47. Lower is better. 0 is zero energy. And then, so you go from 47, and if you're going to implement this as a mandatory requirement, then your adjusted online power production gets you to a 0 on that score. So that's the way it's written today. Some have looked at lowering this number on the left, lowering those numbers, and some have looked at raising this number a little bit. So it's a net 0, not zero energy. But this is the first take. This is the first time it came to the code in the 2021. So there is some discussion about zero energy in the 2021 code, and indirectly with renewables. So there's not specifics for renewables, and so except in the efficiency packages, which I'm going to talk about now. So you build to the code, and then, oh, by the way, you have to choose one of these efficiency packages. So you build to the code prescriptively, you use a software performance pathway, and you then have to pick an option here. And so there's many options. So it could be your heating equipment. And so it has furnaces, AC, it has heat pumps in there, and air and a ground source heat pump. So it has those requirements have to be more efficient or equivalent to those to get credit. So in some cases, builders are already putting a 95% AFUE, those builders that are still building with gas. They're putting a 95%. So if I was a builder, I'd just choose that one, right? Doesn't cost me anything. So, but this is the first step. We see this improving and changing over time. Big leaps don't work in the code. It takes a while to get there. And then service water heating. This is where an option again, you can use your fossil fuel, your natural gas. You can use an EF for electrical, or you can use solar thermal in that. And then you can get credit if you go below 3 air changes per hour. So that would apply to larger units, but you have to have an ERV or an HRV if you get build it to a tighter building enclosure. And again, that's going to bring comfort. And then the simulated pathways where you're using software, 405, it's a section of the code, that is basically a HERS rating. A HERS rater does that type of work. And they have to get, where it says 95% or less than or equal, they have to get 5% better than than the base code. That the software is going to make a calculation. This is where the base code, the reference home should be, and then this is where you need to be to exceed the code. And then 406 is the ERI pathway, so that's an index score like hers. That says 5% less. So if the score was 45, then it's going to have to be a 40, 39, 45, 40. So these are additional efficiency package options. This has been in the code for commercial for 3 cycles now. And it just made it in for residential. So that's where we're making progress. It's not perfect, we're making progress. So the commercial code brought it in, and now the residential code worked hard, and now it finally got in after the third version since the commercial code. And then this is the energy rating index. This is just the base scores, and so these are in the 50s. So in our climate zone, it's a 55. If you did the ERI, it'd be 55 minus 5. So you'd have to come in with a 50 if you chose that. Well, no, actually, you have to choose that pathway with ERI. So there's 4 pathways on the residential code. There are 90.1 on commercial, so there's 4 on the commercial side too for compliance. So this is coming to the code, renewable energy certificates. And this is describing that. There's a definition, and this is because of those options we just talked about. I didn't dive too deep into it. I actually voted against that. I voted, and you can ask me later why I voted against it. Well, I'll tell you why I voted against it. I don't think the building officials, they're the right person to look at the recs and verify the rec is retired. They're going to retire that. Somebody else could, but I don't think it's the building code official. I don't disagree. I'm just saying I don't believe it's the building official's responsibility to do that. We need to find somebody else that can retire that rec. So what's not included in the code, and I'm coming to the end, and we're right near the end. So what's missing? Electric vehicle infrastructure. We thought we got it into the 2021. It didn't make it, but we have. I was mentioning earlier to some people that were here before we started that there are proposals for the 2024 code. One for commercial, one for residential, and there's different, I call them gates, and both EV infrastructure for commercial and residential went through the first gate, which is good. You get through the first gate, you have a better chance of it making it into the code. If it misses that first gate, it could still get into the code, but it's much harder. But I think it's going to be there. And the home builders and the multifamily housing council is supportive if it's in an appendix, if it's not mandatory in the code. If it's in an appendix, they're saying they'll support it. They have their reasons. I think they probably won't support it. I don't know, because I've seen that before. Electrification requirements. Just last week, we had a consensus committee meeting, and that got through the first gate. And what that means is you're going to put natural gas, you're going to put fossil fuels in. You also have to run electrical for your cooktop. You also have to run electrical for your dryer. You also have to run electrical for your water heat. So you can still put in what we call a mixed fuel building, but you have to put in electrical too. So we'll see where that one just barely passed, but it made that first gate. Talk more and more talk about zero carbon and zero energy coming up. And then renewables are not in the code. And so that's been an interesting discussion about renewables is we that have been supporting energy efficiency don't want to lose that energy efficiency. We don't want to allow it to be traded off. So we're saying we have to keep the level of efficiency we have, and then let's add renewables. But as I was in the insulation industry and the trade association, I recognize the job there is to help them sell more insulation. Well, the solar industry, the job there is to help them sell more solar systems. But a house in Phoenix, when the sun goes down and it's 70 degrees in July, it's 7 o'clock in July, and it's still 105 degrees outside, we really want a house that has more insulation, better windows. We don't want to trade those away for solar. Solar's great, but it doesn't work for us when the sun goes down. Now, if you start to add renewable or storage and all those other pieces, then the equation's different. So it's going to come, but it's that progress. And it's that sometimes knocking heads. Yes, let's do this, let's not do that. So that's what I wanted to share. Thank you for your time.
What about solar ready? Anything about making homes solar ready where you have the conduits, the chases for the wiring?
Yes. So I wrote a proposal for the 2015 Energy Code, and I'm not up here bragging, just letting you know. It was in 2015 Energy Code, so I wrote it in 2013. And I wrote it fairly aggressive, but to get it through the process, that progress, we have a solar-ready appendix in both residential and commercial, but it's light. You have to document the pathway. You have to have a certain area on your roof. You have to have it clear. You have to have an open space in your panel, but you don't have to run conduit. You don't have to run wire and so forth. So there is a solar-ready appendix in the 2015 IECC still today, and then it came for commercial, it came in the 2018.
I see a lot of complexity with a core and then options to stick things on. I don't see very good standards in the core or in the stick things on, like fenestration, a U value of 0.3 is not aggressive. It's just a double glaze with a couple surfaces or only one and argon, and doesn't get you a triple glaze. If we want to solve the climate issue, we can't be building those now. We cannot be doing that. And so the codes don't seem to be supporting that. In the area of the mini splits, the HSPF value and the SEER value, the HSPF 10, the SEER value 16.
Right.
Well, I've got a mini split. HSPF is 15. The SEER is 42. 16 is considered good when you can be 42. So do they, and then also, do they talk at all on the windows, back to fenestration, do they talk at all about directionality? In the Northern Hemisphere, where we are, I'm going to have that be as an assumed thing, not talk Australia, New Zealand, but in the Northern Hemisphere, you have an advantage on certain sides of the house to have a different solar heat gain than on others. And so those are trading off depending on the construction of the window.
Yeah. So let me answer that. So residential, complex, progress. We're going to be fighting with the home builders trade associations and others on fenestration. And I've been looking at tuning windows for years in residential. And how do you get there? Well, you make sure that you have different size windows, so you don't mix it up. So you're going to have whatever a 4040 on one side and and those are all one SHDCU factor, and you're going to have 3Os and 303Os or whatever it may be. Now, on the commercial building, yes, I was part of a subcommittee in the 2018 code where we looked at that, and we also did Northern Hemisphere and Southern Hemisphere for commercial buildings. So commercial buildings take that into consideration. Will we ever get that there in residential? I don't think so. I really, just with the makeup of who participates in the code, I don't think but could it happen locally? Yes. That's where you could look at making amendments locally.
Why isn't the base at a stronger requirement? So walls might be R50 and mini splits might have SEER value requirement of 32. Why don't we get in there and do it to save the grandkids? That's the question.
You're right. It is a challenge. You have.
I think I might have missed it because I was multitasking.
Yeah.
But I'm not sure it's become clear how the codes are made or how the sausage are made.
Okay.
Maybe you want to talk
Sure.
a little bit about who is in this pool of people who decide what is going to be the next code.
Okay. How are they? What's that? That's important too. So there's the education piece, training and education of code officials and plan reviewers and field inspectors, and then the building industry too, in the trades. So how is it developed? I will describe it as quickly as I can. All of us here can write proposals. All of us can write proposals for any code, okay? And then we go speak and testify on behalf of these codes. And so we can have product manufacturers, we can have home builders, we can have trades, we can have energy efficiency, we can have renewable advocates, and on that are there, that are submitting proposals. And then today it's a little different. There's a consensus committee, and the consensus committee is mixed up, or not mixed up, excuse me, is made up, mixed up, sometimes it feels mixed up, but it's made up of about 50 people for residential and 50 for commercial. And it's home builders are there, and product manufacturers are there, and efficiency advocates are there, and building officials are there, and the public is there. And so everybody comes together and discusses these proposals and votes it to move forward or votes it not to move forward. So it's us that are developing. In the past, prior to the 2024 code, the final vote was government officials. So it could have been code officials, it could have been plan reviewers, and they were ICC members too. They had to be ICC members and government officials. It could have been a state energy office, could have been Will Tour if he was an ICC member, that would vote on these. And so that's why it's progress, because it's not perfect.
Actually, I'm very glad I asked this question because I think it gives us some ammunition, because there's a lot of complaints about the codes. And if you go on Nextdoor, you'll hear people say, they are telling us, and well, it's us. It's a democratic process, one that is actually extremely rare in the public sphere, to have some consensus building like that, and involvement of different constituencies.
But how is it that these codes must obtain the force of law? Say some state went crazy like Florida and said, we're going to write our own building codes into our state constitution, and they're going to be that way forever because we don't believe in climate change. How would that not be possible?
How would that not be possible?
Yeah.
That's a good question. It would probably have to come from the federal government somehow. I don't know if it would be something that came through Congress and then signed by the president.
No, I'm saying that, like, how do states not just grab a hold of the system and say, okay, we're going to write our own codes because we don't believe in any of this climate change, which could in fact happen? I mean, how are your codes then enforced on, in a situation like that?
In some cases, Minnesota does a lot of their own development of their energy code. Oregon, Washington State. But I'd say those states are still very active in this code development process because they want to be able to go to a ICC code where they don't have to develop it. So I've seen Washington, I've seen the Oregon staff, I've seen the Minnesota staff, I've seen California staff who has their own energy code, their own standards and requirements. They're participating in the development. There's one from the California Energy Commission who's on this committee I'm on right now.
I want to underline this point because just like in industry always wants standards that are reliable and that they can follow and that they can plan for.
Yep.
And the same obviously applies to states. I mean, look at a state like Colorado. I'm from Germany and I was baffled. In Germany, we have a national building code.
Right.
And for instance, for solar, it says you can do solar, period. And if your community, maybe it's a historic little town from the 1500s, says you can't, then they have to have a really good reason and make that case. But in general, you have that right.
Across the country, there are states, some are called min-max. You can't go above and you can't go below. And then there's others that are mins. You can go above, can't go below. And so the min-max are the more challenging ones to get anything done. Then the municipalities have to do it all through voluntary programs, some kind of incentive, accelerated permitting or something to move those buildings, residential and commercial, to where they want to go from a climate perspective or from an efficiency perspective.
Yeah. Let's see. On exterior lighting, you mentioned that, and I was curious. You mentioned it's going to adopt the commercial requirements, industrial requirements. But do those have night sky requirements on there?
No night sky requirements. Nope, I haven't seen
Even on
that.
commercial, there's no night sky requirements
No night sky
in the
requirements.
appendix. No.
Nope.
Oh, that's disgusting.
No, not there yet. And LEED, who does a lot of work with an ASHRAE green building standard 189.1, and they're active in 90.1, which is the commercial building efficiency standard. They have some requirements for lighting direction, but it's not night sky.
Okay.
It's
How
not
about
night sky.
when I saw the item on water heating, you had a value of 2 for electrical energy efficiency.
Yep.
Now I'm guessing a standard electrical hot water heater is an efficiency of 1, right? So 2 means the only way to get there is probably with a heat pump, right?
That's what they did.
That's right.
Yeah, they didn't call out a heat pump. They called out an efficiency factor. That's the other thing. If we're calling out specific products, we could have AHRI, Appliance Heating Refrigeration Institute. We'd have them on your backs, fighting and complaining, saying we're not following or we're exceeding NACA, North American Energy Conservation. I can't remember what the last A stands for, but that says these are your minimum efficiency requirements for
Well, that's
air
good. I mean,
conditioning
that's a
and
big
heating.
advancement. We've never seen a requirement for something more than just an electric hot water heater at a 1-to-1
Yeah.
ratio.
So
right?
that's a
So
win.
that's great.
That's kind of that progress I talked about.
Right.
It's
That's
in the
good.
code, and now that it's in the code, it can be improved.
Right.
You can then raise the numbers or lower the numbers, whatever
Right.
brings more efficiency. Or
I think back to the
Less-
70s, and you think about everybody who put in solar hot water heaters, right? Because nobody had photovoltaics available to you at a price you could afford. So they put solar hot water heaters. But the price of natural gas made that you'd never do one if you ever ran the calcs on it, because it never would make itself pay for itself. But now natural gas is shooting up in price, and so I'm guessing it's more efficient. But what about preheating the water? Aren't we doing something at least to preheat hot water? We shouldn't rely on solar for everything.
yeah, no,
I mean, solar PV, we should preheat it, right? And
Not-
so
you
there'd
know-
be a very basic thing if you could try to do that, a passive house solar
Yeah.
preheating.
It's not there.
Not
It's not
there?
in the code. I haven't seen any proposals
Yeah.
for that in locally or at the national level.
Okay, nobody's pushing
I mean,
for
there's
that, huh?
discussions at local level where you have your separate tank, which is your tempering. You bring
Right.
your cold water into there and let it warm from the
But you
inside.
could maybe get there with not a prescriptive, but a design method of achieving a benefit in your efficiency for your heating.
Yeah.
Yeah.
There is drain water recovery that made its way
okay.
into the codes.
Yeah,
That's been in there about 6 years now. So
okay,
there is that
great.
for water.
So, if I can ask you for one more clarification, because Doug
Yeah.
just brought it up, that difference between prescriptive and I suppose the other part is mandatory. That hasn't become totally clear to me listening to you. Can you
Okay.
describe why do you want to earn points? That was something
Okay.
you mentioned. And what am I forced to do, and where can I wiggle around it and compensate?
Okay.
If that's how that is, that structure is designed.
There is in the newest code, there's a table. It says these are your mandatory requirements that you have to do, and I didn't display that. And so it says if you're using prescriptive, these are your mandatory requirements. If you're using performance, a HERS rater, an ERI, then you have to do these mandatory requirements.
So you can pick either pathway.
Yes.
And then stick by the rules.
Then you have to, correct. So you have that rules within the sections of that code, and then there's this table that says, if you do this, then you also have to make sure you do this with fenestration, you have to do this with insulation, or you have to do whatever it may be.
And is that for each of those sections, like fenestration or wall units or mechanicals? Can you pick mandatory versus or prescriptive versus performance-based for each of these differently?
So depending upon your pathway that you choose, there's mandatory requirements. A lot of them overlap, so you have the same mandatory requirements in each of the pathways, but there's some where there are some differences. So it's not dramatic. For the most part, 80% is the same mandatory requirements. And then there's some difference prescriptively, and there's some difference if you're doing a software performance pathway or an ERI.
And would you happen to know how builders, you call them production homes, typically decide? Are they going the prescriptive way or are they going the performance way?
Good question. They are production builders, tract homes. They are going a performance pathway because they have more options. Because if you do that table, and you saw that, we had to do what was it, an R60 in our attic? They might not have to put an R60 in the attic by doing a performance path because they're doing something else. They're putting in a better window. Or their air leakage is not at 3 ACH, it's at 2.5 ACH. And so they like that performance pathway because it gives them more flexibility. And they see it as the prescriptive pathway is great for additions, great for homeowner builders. But from a production builder, they like to reduce their costs as much as they can. So they're looking at trade-offs.
And on that note, and I think we'll be finishing up with that, and we can talk some more over the munchies, is that I'm very happy to have just heard that testing is now mandatory, because we've had a lot of talks about passive house, and there are a lot of people who think they're picking a few passive house standards and then they're trying to build towards those and hope it will be good enough. But as the passive house community very well knows, unless you really test the performance of these measures, you will never find out whether the people who built that house actually taped all those gaps and stuck to the rules and used the right materials.
Yeah. I mean, visually, we just can't see it. We might look at that duct, we might look at that wall assembly, and it looks sealed. But unless you
had a
start to
good
do
laugh
some
when
diagnostic testing,
I had a good laugh when you mentioned that the ducts were visually inspected.
Yeah.
I mean, if you take a boat out for the first time, you don't visually inspect it because if it leaks, you're getting wet or dead.
you'll know.
Jim.
Anything about orientation or trees and landscaping? Nothing about nothing related to like the basic passive house
There is
exterior stuff.
right in the the solar ready chapters or appendices, for commercial and residential. Then you have some, if you've got tree blocking shading, if you've got another building or some other structure shading, so it looks at that. The performance pathway does look at that, but it's all within the software. So it's going to look at it. So you're not going to see trees in new construction, right? You'd see another building. You could be a single story, a one story, and a two story where you might have blockage. And so then that individual doing the analysis should be putting that calculation into that software. But for the most part, production builders, the energy raters that do the analysis, they do what's called a worst case. So they orient that house to be the worst case, to be the most energy consumption. So it might be the best energy consumption if it's facing south, think the front door. And the worst might be facing northeast. And that's what they do. So they run that, and then they have a plan that the building department accepts for all of those plans. And they've taken worst case, so it can't be worse than that. If it faces south, it'll be better. What happens, though, is, you might have a system that's oversized because there's good solar heat gain in the winter months, or too much solar gain in the summer months for cooling needs. So that could happen. But that's what the industry has done. Energy Star has gone with that. You don't have to look at the orientation of each home. You just do a worst case in that development. So that piece is there. And then in the solar ready chapters, then it talks about shading for the solar ready zone. So if it's trees or whatever it may be.
So that's 19. One perhaps last question that occurred to me. I'm looking at that passive house space a lot because it's really intriguing. There's so much building science that upends what was previous practice. And they're being helped a lot these days by software. And what I mean by that is, in some ways, there isn't an excuse anymore for building badly because you can run your plans through software and find out where the weak points are and then do something about it.
Right. Yeah, even the architects have software
that
can look at those weak points and can look at orientation too. It's not necessarily an Energy Plus package or a ResNet software package, but they have that ability too to look at that. So you're right. With the software, we can build fairly efficient homes and fairly efficient commercial buildings.